Chapter 11.6, Adding and Subtracting Rational Expressions, this time with unlike denominators. And so how do you add or subtract fractions with unlike denominators? Well, we need to get the denominators to be the same in both of our fractions, and then we can add and subtract them. So the first step to getting that done, in the case of 16x to the 3 and 24x squared, let's say these are our two denominators. We need to find the least common multiple between the two. So how would we do that? Well, first we'll go ahead and do a prime factorization of 16x to the 3. So that's going to be 2 times 2 times 2, and that's 8 times 2 times x times x times x. Right? And we could double check that. That's 4, 8, 16, x to the 3. And then we'll do the same with 24. So it'll be 2 times 2 times, that's 4, times 2 is 8, times 3 times x times x. And we could double check that. That's 4, 8, 24, x to the squared, right? X to the 2. So what's the least common multiple? Well, the top has 3 2's, and the bottom has 3 2's. So I'll underline those. The top has 2 x's, and the bottom has 2 x's, so I'll underline those. Right? The top doesn't have a 3, the bottom doesn't have another 2. So what is the least common multiple? It's going to be 2 times 2 times 2 times x, or that's going to be 8x squared. Right? So I'm going to put that over here, 8x squared. Now that's going to be helpful in finding the common denominator, right? To make the denominators the same. We'll learn about that in a little bit. Let's next take a look at this example. We have two denominators. We have x minus 5 as one denominator, and we have x plus 7 as the other denominator. Right? If we have this situation, then how can we figure out the common denominator? Well, this is one factor. This here is another factor, right? For them to have the same factor, we need to multiply those two denominators together. So another way to think about it is the first denominator has x minus 5 as a factor, and the denominator at the bottom has x plus 7 as a factor. Right? And so what's the least common multiple? Well, there is no least common multiple. There's no factor in the numerator that's the same as the factor in the denominator. So the only way to figure this one out is get the LCD, get the least common denominator, which would mean you would multiply the two together, right? Like so. So that's our LCD over here. X minus 5 times x plus 7. All right, so now let's look at example 3. And so now we have this fraction here, right? And this fraction here, you see the denominators? It's 16x to the 3. And the denominator here is 24x squared, right? So what we want to do is we want to get them to have the same denominator. So what do we need to do? Well, on this one here, we need to multiply by what the multiple that this top prime factorization doesn't have when compared to the prime factorization of 24. Right? This up here is the prime factorization of 16x to the 3. This is the prime factorization of 24x squared. So if we're trying to find a common denominator, we need to multiply this by whatever factor is missing from here. Right? So you can see they both have the 3 2's, they have the 2 x's. Right? What is this top prime factorization missing? It's missing the 3. Okay, so we need to multiply this here by 3 times 3. And now to get the prime factorization, the common denominator of 24x squared, right? So that these two have the same denominator, we need to multiply this prime factorization by what it's missing when compared to the prime factorization of 16x to the 3. So this prime factorization is missing a 2, and it's missing an x. So we're missing 2 times x. So over here, we need to multiply by 2 times x. Okay. Now if we work that out, you could see this is going to become, what, 30 plus 18. So it's going to be 48x to the 3. Right? Put it in a calculator. You look at this one, we multiply it, it's going to become 48x to the power of 3. Right? So that's how we get common denominators. But if you remember, we can't just multiply the denominator by 3, right? Or over in this case, we can't just multiply the denominator by 2x. We need to multiply by 1. And so we need to multiply by 3 over 3. Right? That means we're multiplying by 1, which means we're basically not multiplying by anything at all. All right. So now that we're here, what are we going to get? We're going to get 3 times 5x plus 9 over 16x to the 3 times 3. Okay. We'll go ahead and do the math, and we'll distribute in the numerator. We got 15x plus 27 over 48x to the 3. All right, great. Now let's do the same over here. We can't just multiply the denominator by 2x. We need to multiply by 2x over 2x, or 1. Right? And if we do that, we'll get 14x in the numerator, and in the denominator, we'll get 48x to the 3. So you see, we've converted these two fractions to have the same denominator. So now we can add and subtract them. Right? All right, and now how do we do it? How did we do it as a refresher? We took 16x to the 3, we turned it into its prime factorization. We took 24x squared, we turned him into its prime factorization. We looked and saw what is 24x squared missing from the prime factorization of 16x to the 3. Right? It's missing a 2 and an x, a 2x. So that's what we're multiplying our fraction by here, 2x over 2x. Now we're looking at the prime factorization of 16. What is he missing from the prime factorization of 24? He's missing that 3. So we're going to multiply this fraction here by 3 over 3. And if we do that, we'll get the same denominator. And then we can add and subtract them. All right, let's look at this last example, number 4. So how do we turn these two fractions to have the same denominator? Well, we know that the lowest common denominator is just them multiplied by each other. Right? So what is this prime factorization of this denominator missing when looking at this prime factorization of the second denominator? It's missing an x plus 7. Right? So I'm going to multiply here by x plus 7. But we know we can't multiply by x plus 7, right? We need to multiply by x plus 7 divided by x plus 7, or 1. All right. Now, what is this prime factorization missing when looking at the prime factorization of x minus 5? It's missing an x minus 5. So I'm going to multiply by x minus 5 over here. But of course, I cannot. I need to multiply by x minus 5 over x minus 5, or 1. So now we go ahead and multiply out, and we'll get x times x plus 7 in the numerator, and we'll get x minus 5 and x plus 7 in the denominator. Over here on the right side, we'll get 2x to the 3 times x minus 5 in the numerator, and we'll get x minus 5 times x plus 7 in the denominator. So you see, we now have two fractions. We've converted them to have the same denominator, and so now we can add and subtract them. Okay. Yep. So that's how we find the least common denominator.